Let's take a look at this example. This time we're supposed to find the real part of this complex number, imaginary part, and we're supposed to find the conjugate. There is no question that we are talking about the rectangular form. Anytime you have form with j, it means we are talking in terms of the rectangular form. A is my real part. The part without j is my real part. The part with j is called imaginary part, okay, because j is the imaginary number. So let's take a look at this example. So my real part, my a, is -3. That's why I'm going to write that my real part is -3. My imaginary part is -4. -4. And if you want to find the conjugate of the complex number, you're supposed to simply change the sign which is next to j to opposite. So if I have negative sign next to j, in order to find conjugate, I have to change this to positive. That's why the conjugate is going to look like this: -3 plus j4. And these are the solutions to my problem. Let's take a look at this example. This time we're supposed to find again the real part, imaginary part, and conjugate of -5. But you're supposed to realize that we are dealing right now with pure real number. But you can always make the complex number by adding j0. So the real part is equal -5. Imaginary part is 0, right? And if you want to find the conjugate of this complex number, you're supposed to realize that j times 0 gives me 0. So my conjugate part is equal simply to the real part, which is equal -5. Why? Because this is 0, right? My imaginary part is equal 0. 0 times j gives me 0. And no matter what sign you are going to have, you are going to end up only with -5. That's why these are the solutions to my problem. Let's take a look at this example. The real part is the part without j, so in this case is 2. The imaginary part is the part with j, which is equal 7. And if you want to find the conjugate, you're supposed to simply change the sign which is next to j. So conjugate is 2 minus j7. So these are the solutions to my problem.